Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many ways can a committee of 4 people be selected from a group of 10 people? Imagine the situation. If there are 10 people and you're selecting 4 out of them, it doesn't matter who will be called first. Because once all 4 have been identified in any order, they will comprise the committee that is formed. In short, we're talking about combination here because the arrangement of the people that are called to be part of the said committee, it doesn't matter. So we'll be using here the combination formula, N, C, R. Our N here corresponds to the number of people. We have here 10, and we'll be taking 4 at a certain time. That would mean our notation here would be equal to 10, C, 4. You can just simply automatically apply this in your calculator to know the final answer. But this time I'm going to show you the process so that you would know the correct procedures in solving for this item. Again, this is on combination because it doesn't matter the arrangement of the people on the said committee because there's no label for who would be the head, who would be the scribe, just the members. So that would mean we're talking about combination. The formula for combination is N factorial over, you will have your N minus R factorial times R factorial. So your N is 10 factorial to be divided with 10 minus 4. The result of that would be under factorial, and you will have your R, which is 4 factorial. You would know that your answer is, or your denominator is correct when you see something like this. Of course, your numerator is 10 factorial. Your denominator is 10 minus 4. That's 6 factorial times 4 factorial. Let's just simply talk about the numerical expressions, not the factorial notation, okay? 6 plus 4 is 10, but not 6 factorial times plus 4 factorial, okay? Just the number 6 and 4, 10, you would know that that's correct. We know that an n factorial is the condensed way of writing the product of 1 to n integers. You have n times n minus 1 times n minus 2 until you reach 1. That would mean your 10 factorial can be written as 10 times 9 times 8 until 1. So times 7, but this time let me just end at 6 factorial. The reason for that is since I already have a 6 factorial here on the denominator, I could automatically cancel that. Of course, I could continue with 6 times 5 times 4 times 3 times 2 times 1, the same with the denominator, but nevertheless, I could cancel both of them. I still have 4 factorial here. Now, I could input all of this in a calculator, but since I'm trying to answer this without the use of calculator, let me just also express this here. 4 factorial is 4 times 3 times 2 times 1, right? Because that's the same concept here. Now, take into consideration the 4 times 2. 4 times 2 is 8, right? So I could cancel that here, cancel that, and cancel here. Now 3, okay, I'm just removing this 4 factorial because we already have this representation here. 3 can be removed from 3 here. So 9 is 3 times 3. So I still have 3 here. I have removed that. So 1 is just 1 itself. I'm doing this so that my entire denominator is just equal to 1, and even without the use of calculators, I am sure that my answer will not include any fraction. This would mean that the result here is just a product of 10 times 3 times 7 because I already removed 8 by 4 and 2 at the bottom, and 9 becomes 3 as we also remove the other 3 on the denominator. Again, that's 10 times 3 times 7. So we will have a result of 210 possible committees that can be formed using 4 people from an already identified group of 10 people. So there are only 210 ways. That is how we answer this because this fits the combination concept, and that's count it in. Talking about getting the luck of the draw. For all in, subscribe now.